Hi, let's see the first exercise. Consider some arithmetic progression sequence that it is finite, having 7 terms, and we know this about that sequence. I'm not going to give you time. If you want, you can just pause the video, but the idea here is not an exercise, okay, per se, but only a discussion just after the theory. So what can we say about this information? Well, let's write it down. Okay, A1, A2, A3, 4, 5, 6, and A7. Okay, remember that rule. Okay, I know that for here is very easy, but remember the rule. How can we find the middle term? Of course that for this one is very easy, but how can you find it? Okay, let's put it here. Finding the middle term. Remember, we just take 7 divided by 2 and we have 3.5, and round to the nearest integer, and in this case it's going to be what? 4, right? So 4, it is the middle term. Okay, again, let's make it green. This is the middle term. Central term, okay, middle, the same. Now, and what is being given to us? A2 and A6. Again, those are the pairs, right? Okay, so we have 3 pairs. And remember that the summation of all of them are going to be the same. Okay. Now, let's call this summation like x, y, and z. Okay, so the summation, that's what I'm stating. A1 plus A7, it is going to be x. A2 plus A6 is going to be y, and A3 plus A5, it is going to be z. Okay, so using the last property, meaning the summation of the extremes are the same. Okay, when you just add those, it is the same as adding those and adding those. So for that, we just know that x equals y and equals z. Now, and we know that A2 and A6, it is 256. So this is given to us, right? Okay. Now, what can we say? We can find out what is A4 in 2 ways. Okay. So what is the first way we can find out? Well, A4, remember, A4 is just half of this. Okay, or in another way, we can say that A4 plus A4, it is going to be 256. Okay, or we can write like this: A4 plus A4 is going, it's like let's put it here. Okay, no, I can't put it here. Okay, so A4 and plus A4 is going to be like M, and M, it is also in here. Okay, because I don't have 2 A4s in here, so it's not going to work. Let's even cover that. Okay, that's not going to work. Okay. Okay, so that it's very easy. Okay, there is not much more to say about it. It's very straightforward. Okay, so what is A4? Just judging by that, A4 is going to be 128, if I'm not mistaken, right? 128. Yes. And just remembering, okay, you have to know that sequence, okay, like 2, 4, 8, by heart, 16, 32, 64, 128, 256, 512, and 1024. This sequence you have to know, okay, because what is this? This is going to be, I'm going to explain why this is very important. Okay, this is going to be 2 to 1, the second, third, to the fourth power, 2 to the fifth power, 2 to the sixth power, 2 to the seventh, 2 to the eighth, 2 to the ninth power, 2 to the 10th power of 10. This is very important, okay? So that sequence you have to know by heart, the red one. And there is nothing much to say, okay? It's very straightforward. Now, in the same video, let's make another one. Consider this arithmetic progression of 350 terms. We know that A81 and AM are extremes equidistant terms. Okay, they are like this, like the A1, A7, A2, and A6. And what I just want to know this: what is M? Okay, I mean the value, of course. I don't want to know what's M. Okay, what is the value of M? What is going to be? It's going to be A20, A100. Okay, what is going to be the number, the position of this term? Well, now I just wanted to think about it. Okay, if it's very easy for you, good. Okay, but if it's not, pause for a moment and think. Okay, so what is the equidistant of 81 in that sequence? Well, to start with, let's start like this. For the first term, the equidistant is going to be like 350. Okay. Now, if we have the second, but I'm just going to write now the index. Okay. For the second term, the equidistant, it would be 249. For the third term, it would be what? 348. Okay. Now, what about for the term, the n term? What it would be? Well, what is going on in here? It's just like if we just take the 350 and we subtract, this is just 1, okay? If we subtract 1 and add 1, I mean, you subtract the n, right? Let's make this one, it's easier. What is 348? Let's expand this. We could write that this would be 350 minus 3 plus 1. Okay, so what is going to be n? N is going to be like 350 minus n plus 1, right? So this is like 351 minus n. So if you had to find out the general formula for the equidistant terms, as we have the n term, the equidistant term, it will be what? 351 minus n. Okay, for instance, let's suppose let's suppose we have n equals 10. What is going to be the equidistant term? This is going to be what? 351 minus 10. This is going to be 341. They are equidistant. Now, what about n81? Now just plug in. This is going to be 381 minus 81, and this is going to be what? Okay, 50 and then 30, 270. Just that. Okay, so this is what it's going to happen. This is going to be the central. This would be a 270, and this would be a1. In the same way, this would be like a10, and this would be a341, and so on. And those are equidistant in the same way as those are also equidistant terms. Okay, the same is here, right? Equidistant terms. Okay, it's just a very simple formula when you don't know, okay, because sometimes, okay, divide by 2, sometimes it's dangerous to just take 350 minus that. If you just did 350 minus that, it would be wrong, okay? So whenever you don't know something, the tip I can give to you is make it very simple first, okay? Make it very simple, okay? And when you just make it very simple, we can try to make that onion becomes simpler, and then we can find a rule. And as we know the rule for the simplest case, we can start to complicate it and get to the more complicated case. This is true even for life, okay? When you don't understand something, make it very simple, understand that very simple issue, and then you start to add the layers, and then layer by layer you are going to get to that more complicated issue. But if you don't start from the center, it's impossible.